Okay.
Howdy, this is Sofia Guerra and Cassie Fernandez, and today we're going to be speaking on innate immunity, the body's first line of defense, an overview of its components, mechanisms, and functions.
Introduction. Innate immunity is the body's first response against infections. Its characteristics include immediate, nonspecific, which is mainly for innate immunity, and it does not create memory. Components including physical barriers, immune cells, and the complement system.
Moving on to physical barriers, our first layer of defense is the physical barriers. The skin acts as tough outer shield, while mucous membranes trap microbes. Secretions like saliva, sweat, and mucus contain antimicrobial compounds that help neutralize threats.
Cellular components of innate immunity. Innate immunity is powered by specialized cells. Neutrophils and macrophages engulf and digest invaders, while dendritic cells present antigens to adaptive immune cells. Natural killer cells patrol the body to eliminate infected or abnormal cells.
Pattern recognition and toll-like receptors, in other words, PRR and uh, TLR. Immune cells use pattern recognition receptors to detect microbial signatures. Toll-like receptors, for example, recognize bacterial and viral components, activating pathways that lead to inflammation and immune defense.
The complement system. The complement system is a powerful biochemical pathway that helps eliminate pathogens. It codes microbes for easier recognition by immune cells, triggers inflammation, and directly lyses microbes through the membrane attack complex.
Cytokines and their role. Cytokines are like messengers coordinating immune responses. Some drive inflammation, while others, like interferons, especially target viral infections by preventing viral replication and enhancing immune cell activity. Here we have an image showing some of the different kinds of cytokines where we have TNF, IL-1, IL-6, and IFN-A, IFN-B.
Acute inflammation. It is a rapid response to infection or injury characterized by redness, heat, swelling, and pain. It involves leukocyte recruitment, vasodilation, and increased vascular mobility. Inflammation is a key response of innate immunity. It recruits immune cells to infection sites, increases blood flow, and promotes healing. The classic signs, such as redness, heat, swelling, and pain, are all due to immune activation. And here, as you could see in the image, these are the three main components that come from acute inflammation, which is injury, infection, and then inflammation, and then progressively healing through the process of vascular permeability and MAC cells and phagocytosis working together.
Fever as an immune response. Fever is triggered by pyrogens that reset the body's temperature. Higher temperatures slow microbial growth and enhance immune function. Fever is often seen as a symptom, but it's actually a defense mechanism. The body raises its temperature to hinder pathogen replication while boosting immune activity. This control response can be beneficial when fighting infections.
Microbial, microbial evasion of innate immunity. Some pathogens have strategies to evade immune systems, such as bacteria and a virus. Bacteria may produce capsules to avoid phagocytosis, and viruses may inhibit interferon signaling. Microbes are constantly evolving to bypass our defenses. Some bacteria produce protective capsules, making them harder to engulf, while viruses can suppress interferon responses to continue replicating. Understanding these tactics helps in developing better treatments.
Innate and adaptive immunity connection. Innate immunity provides signals that activate the adaptive immune system. Dendritic cells present antigens to T cells, linking the two responses. Innate and adaptive immunity work hand in hand. While innate immunity acts first, it also primes the adaptive response. Dendritic cells play a crucial role by presenting antigens to T cells, guiding the body's long-term immune memory.
And finally, the summary and conclusion. Innate immunity provides an essential first defense through barriers, immune cells, cytokines, and the complement system. It activates inflammation, fever, and adaptive immunity. Understanding innate immunity is crucial for disease prevention and immunotherapy development. To summarize, innate immunity is our immediate defense comprising barriers, immune cells, and biochemical responses. It acts quickly to eliminate threats and prepares the adaptive immune system for a more targeted response. A deeper understanding of innate immunity helps in disease prevention, vaccine development, and immune therapies. Thank you for your time. I'm going to start recording already.
Okay.